Hi there. As a part of AgilePoint's version 10 release, we're happy to announce support for OpenAI. Over the course of this video, we'll first show you how to connect to OpenAI and use the various process activities and AI control towers as a part of a sample application. So to get started, we'll move into Manage. Under App Builder, you'll see Global Access Tokens. So what I'll be doing here is creating a globally reusable connection into OpenAI that has its own permission framework. But bear in mind, we can always create app-specific tokens. So let's go ahead and search for OpenAI. Now in my case, I already have a few configured, but as you're seeing here, the configuration is pretty straightforward. So first, we'd give our token a name. Now the only bit that we'll need from the OpenAI side is the API key here. So after entering that, if you're creating this for the first time, go ahead and click Test Connection. Now, further down here, you're seeing I can specify the model that's tied to this token. This is really going to be handy from an ongoing manageability perspective because it centralizes model selection at the access token level, rather than having different configurations for various models at different processes and, of course, the various activities. That being said, if you do unselect this, you still will have that capability. Now, in my case, I'm going to go ahead and back out because I've already created my token. Okay, so that brings us to the use case for today. Now we're going to go through the demo scenario here in just a moment, but first I'd like to go through the various activities within the OpenAI activity group. So first, we have a number of activities that can be layered in inline as a part of our process. You might have seen the other video that touches on this topic, but here you're seeing analyze an image, chat completion, create an image, or text moderation. Now this video is really going to focus around the AI control towers as you're seeing here across the top. So we have a few different categories, first being analyze image, and then analyze image in a number of additional activities to adapt the flow, inject an ad hoc task, initiate a sub-process, or send a notification. Similarly here with chat completion, and a number of other chat completion activities to adapt the flow, inject an ad hoc task, initiate a sub-process, and send a notification. Okay, so for the use case for today, we have an insurance claim application, and it has all of the typical steps that you might expect. After having an accident, an insurance customer will open up a claim by calling into the call center and providing initial details about the accident. From here, the process will flow externally back to the customer where they can provide more detailed information about the incident. And from here, a number of internal steps for claims handler, assessor, and so on. Now, across the top, we do have 3 AI control towers, all coming from the OpenAI Control Tower stencil. So first, we have an image classification agent. This will use computer vision to analyze the customer-provided image showing damage to the vehicle. Those insights will be handed over to the claims analyzer agent, who will essentially compare the output from the image classification agent to the customer provided description of the accident. And these two agents will hand their insights over to our final fraud predictive agent, which will make an ultimate determination as to whether fraud is likely in this claim. Now, if so, what you'll see here is this control tower will stop the typical processing and actually inject additional levels of review that we don't have here at design time for our fraud investigation team. So let's get started by taking a look at our image classification agent. So as you're seeing here, this is using the Analyze Image Control Tower activity. Okay, for image selection, as you're seeing here, I can get the image from a URL or base64, but in my case, I have the image uploaded in a source repository. And as you can see here, I've configured Box as that repository. As a next step, I'm going to select how I'm connecting into OpenAI. So I have my global access token. In my case here, the use model configured in the access token is grayed out. I did not prescribe the model at the access token level. So as a result here, I can select from a number of different models under this connection and a number of additional model parameters. Moving into the system instructions, as you're seeing here, I have a number of tabs that I can configure. The goals and mission include analyze an accident car image to identify visible damage to specific parts of a vehicle and return a structured damage assessment. The goal being to provide clear, consistent, machine-readable damage report that can be used in insurance claims processing or automated workflows. Now, down at the bottom, you're seeing here an option to save this to OpenAI. This essentially saves my instructions as a template. And then down below, you'll notice here there's a warning to verify model token limits. Now, depending on the model that we select, there might be different context length limits. And these limits would apply to all of the steps here within my system instructions. So the skills include computer vision-based image analysis, vehicular damage detection, visual inspection and classification, structured data generation, raw JSON formatting and validation, and rules-based decisioning. Now the input is going to be a single image of a car involved in an accident. The image may show partial views, multiple angles, or varying lighting conditions. Various instructions. So here we're basically determining whether the following parts of the vehicle are damaged: broken headlight, broken windshield, frontal damage, and so on. In this case here, I do have a quality verification step. As you're seeing here, I have a number of instructions that I've provided, and the output here being in a JSON structure. Moving over to our triggering event, the AI control towers are event-driven and can provide additional filter conditions. So as an example, this control tower will be invoked when the customer engagement step has been completed. Okay, so from a request mapping perspective, you'll notice here this is blank. We are passing the entire image. And then from a response perspective, you're seeing here the JSON structure has been extracted from my system instructions. And as a result here, you're seeing a relatively straightforward mapping. Now in my case here, I have nothing under the parsing section because I'm already mapping it back to the Agile Point schema. I have no need to do any JSON sort of parsing. But if I am storing that JSON in a variable and later on want to parse that information out of that JSON, you can always do regular expression, inline functions, and again, JSON parsing. And underneath actions, you're seeing here, this is blank because we're just getting the response back from our vision model. Okay, so let's take a look at our fraud predictive agent. So here, as you're seeing, we're using the chat completion activity with the ability to initiate a new sub-process. So again here, connecting to OpenAI, the model I'd like to use, different model parameters, but let's take a look at the system instructions. So as you can see here, the overall goal and mission is to analyze the insurance claim data to identify potential indicators of fraud, assess claims for anomalies, inconsistencies, or unusual patterns or risk factors, and produce a fraud prediction. Various skills include insurance domain understanding, fraud pattern detection, temporal analysis, financial risk analysis, rules-based and heuristic reasoning, and clear, explainable decision making. All right, you're seeing here the input parameters, instructions, and quality verification. And again, the output. Okay, so the triggering event here is going to be the wait for milestone activity when that has completed. Now, under the trigger condition, I have provided additional filters. This is a very powerful capability that ensures AI is acting upon the most impactful sorts of cases. So as you can see here, I've provided additional filters. Our request and response. Nothing here under parsing, but under actions, we're going to see the typical process flow adapted in the event that fraud is likely. So here, I'm prescribing the sub-process I'd like to invoke in the event that fraud is likely. And additionally, I have provided additional rules. So as an example, if the fraud prediction is equal to fraud and the probability is greater than 50%, and then you're seeing here things like, is this a human authentic report? False. Key conflicts exist in facts? True. In which case, invoke that sub-process. Now we're going to skip over the claims analyzer agent. The configuration is very similar to our fraud predictive agent. So now that we understand the application and how the various AI control towers will work together to optimize process execution, let's go ahead and run it. Okay, so first things first, as the call center employee, I'm going to bring up the details of the customer involved in the accident, starting with a lookup of their policy ID. From here, we can determine the vehicle in the accident and the driver involved. Next, we'll capture initial high-level details about that accident, the third party involved, prior claim history, and we'll leave a comment to open up the claim. Okay, so a process has now kicked off behind the scenes. So let's open up our process tracker. Okay, so now we're sitting with an external step. This is leveraging AgilePoint's anonymous forms, which supports secure external participation, which means it's time for me to assume the role of the customer. So I've received a task where I'll provide more detailed information about the accident. Now we're going to start here with the image that will be fed into our vision model. So as you're seeing here, there's pretty clear damage to the entire front of the vehicle, the windshield, the headlights, the tires, etc. So let me go ahead and upload that. Okay, so we've uploaded our image, and down below is a more detailed description of the accident. So what I'd like to do here is introduce some pretty clear conflict between what's shown in the image, namely damage to the front of the vehicle, and the accident description. So I'm going to change this from front left side to the back of the car. So again, pretty clear conflict, and we'll submit this. So coming back into our process tracker, we're going to see indicators for our various AI agents invoked one by one. First will be our vision model, analyzing the image that I've just uploaded. Those insights will be handed over to the claims agent, which will determine whether the output of our image classifier lines up with the accident description. And these two agents will hand their insights over to our final fraud predictive agent to make that final fraud determination. And again, in the event that fraud is likely, we're going to see the typical processing paused, and a new step will be dynamically injected for additional levels of review. So as per the process monitor, we're now sitting with the claims handler step, but if I go back into my task list, we're going to find that that step has been paused. So as you're seeing here, this task has been paused as fraud is likely. We need to clear this exception scenario before we unlock this step. And as you're seeing here, a subject matter expert has now received a fraud alert. So moving into this task form, what we're going to see here are suggestions coming back from our AI control tower agents, as well as all of the insights uncovered by AI. Okay, so as you're seeing here, our vision model has clearly identified damage to the entire front of the vehicle, including tires, etc., as we showed earlier. Our claims analyzer agent has basically determined that though this is human authentic report, there are key differences or key conflicts to be aware of, which gives us the sense that fraud might be likely. And as a result here, the control tower is suggesting we inject an additional level of review for the fraud investigation team. So I want to go ahead and assign that to myself. And what I want to do here is just keep the lock on all of the downstream steps until this investigation is complete. Okay, so if I refresh my task list, I'll see that investigation step activated. So here, as an investigator, I can leverage the AI insights as well as my domain experience in the insurance industry to make a final determination. In this case, is fraud likely? So I'm going to skip over to the investigation tab. I've taken an offline action to review police and fire reports. And here in this case, I'm going to go ahead and send this for further processing. Based on everything that I'm seeing here, this was a customer who was a bit shaken up after having had an accident, likely no fraud in this case. Okay, so now that we've cleared the exception, the claims handler step will now be active. So in other words, from here on out, the process will resume as per usual. And as a result, this is going to conclude the content for this video. Thank you so much for watching. I hope this gives you a better understanding of how to leverage the OpenAI Control Towers as a part of an application. And most importantly, orchestrating multiple agents using various types of artificial intelligence. So thanks again, and we'll talk to you soon.